5a, we're going to be doing some more differentiation. And in this case, we have an example of a problem where doing quotient rule will be the best method to tackle this. Now, while we do have multiple terms in the numerator, and in the previous problem in number 4, we did it by dividing each term in the numerator by the denominator instead of using quotient rule. In this case, that's not going to help us too much because this denominator is not going to be able to cancel with anything that happened in the numerator. In problem number 4a, it made it so that we had easy term-by-term differentiation. It wouldn't happen here. So we're just going to use the quotient rule. So to do that, you obviously need to remember what is the quotient rule. So remember that your quotient rule says that if you have f of x over g of x, the derivative of this is going to be f prime of x times g of x minus f of x g prime of x all over your g of x function squared. So we have derivative of the top times the bottom minus the derivative of the bottom times the top all over g of x squared. That's your quotient rule. So we're just going to apply that here. So the first term is the derivative of the top times the bottom. So the derivative of the top here using your power rule would give you, so let me write h prime of x here. This would give you 2x minus 1 times the denominator, which is x minus 1 to the 2/3. Our second term of our quotient rule is just the top, x squared minus x plus 1, times the derivative of the bottom. So the derivative of x minus 1 to the 2/3, we're going to use power rule. But since we're taking the derivative, or since our base is x minus 1 and not just x, we have to make sure we consider what the derivative of that base is. Now the derivative of x minus 1 is just 1, just like it is if it was x. So in this case, we don't need to do anything different. But that's an application of the chain rule. So for example, if this part that you're taking, raising to the 2/3 power, was more complicated, like it had an x squared in it or there was a coefficient in front of the x, then we would need to use the chain rule to make sure we multiply by the derivative of that as well. But since the derivative of our base is 1, we don't need to take that into account, and we can just use power rule. So that's going to be 2/3 times x minus 1, and we're going to lower this power by 1, which would be negative 1/3. When we put that all over the denominator squared, the denominator x minus 1 to the 2/3, if you square that, you would just be multiplying the power by 2. So we're going to get x minus 1 to the 4/3. All right, so there's a couple things we can do to help simplify this. So if you notice, we have an x minus 1 to the 2/3 here and an x minus 1 to the negative 1/3 here. If we were to multiply the top and bottom here by x minus 1 to the 1/3, what we would do is we would change this to a whole power. This would disappear because we would get rid of the negative 1/3 power. And we'd have to do the denominator by the same thing. So in order to simplify, I'm going to do that. I'm going to multiply top and bottom by x minus 1 to the 1/3. So this is going to help us simplify our numerator. So by doing that, so my numerator would now become 2x minus 1 times x minus 1, because the x minus 1 to the 2/3 times x minus 1 to the 1/3 would just give you x minus 1. And then we can subtract x squared minus x plus 1, and we have also times 2/3, which I'll write at the front of that. And this part will cancel out because x minus 1 to the negative 1/3 times x minus 1 to the 1/3 would just give you 1. Then our denominator is now x minus 1 to the 4/3 times x minus 1 to the 1/3, which is x minus 1 to the 5/3. So now we're looking a lot simpler, and we have one more step to do. We can FOIL out this term, distribute the negative 2/3 here, and then combine all like terms. So off to the right, I'm just going to write what the numerator would be. So if we FOIL this, 2x minus 1 times x minus 1, that would give us 2x squared. We'd have minus x minus 2x, so minus 3x plus 1. That's from FOILing this. Here we could subtract or apply the negative 2/3. So I'll write these kind of like in line so we can subtract them out. So this is going to be negative 2/3 x squared. This would be plus 2/3 x. And then we get minus 2/3. So if we combine all our like terms and rewrite our derivative again, so we get 2x squared minus 2/3 x squared. So that's going to be 6/3 minus 2/3. So that's going to be 4/3 x squared. Negative 3 plus 2/3. So that's negative 9/3 plus 2/3 is going to give us minus 7/3 x. Then we have 1 minus 2/3, which is going to give us plus 1/3. All over x minus 1 to the 5/3. So this is combining all of our like terms in the numerator. And then the last step we can do, since these are all divided by 3, we can just put that 3 on the denominator and make this 4x squared minus 7x plus 1 all over 3 times x minus 1 to the 5/3. That looks the most simplest, and that's going to be our derivative here of the original function. Again, applying the quotient rule.
The Teaching Center, UF's Learning Resource Center.